system of nonlinear equations is a system of two or more equations in two or more variables containing at least one equation that is not linear. Recall that a linear equation can take the form ax plus by plus c equals to 0. Any equation that cannot be written in this form is nonlinear.
Number 1. It represents the intersection of a parabola using substitution. Number 2. It represents the intersection of a circle and the line using substitution. Number 3. It represents the intersection of a circle and an ellipse using elimination.
To find the solution to this, we need to determine the value of x and the value of y, such that when these values are substituted into equations, they will satisfy both equations. The solution set to this system may consist of one or more variables of x and y, which are the points of intersections of the graph of these equations.
Let me show you an example in solving system of nonlinear equations using the first substitution. The first example is x squared plus y is equals to 26 and y is equals to 3x plus 16. Step 1. Substitute 3x plus 16 for y in equation 1, then simplify the equation. For our step 2, we need to factor the left side of the equation. Use the zero product property to get the value of the x as our step 3. For our step 4, substitute the values of x in equation 2 to get the corresponding values of y.
To check the answers, substitute the values of x and y in equation 1 and equation 2. First, substitute negative 5 and 1 in equation 1. Then substitute 2 and 22 in equation 1. After that, substitute negative 5 and 1 in equation 2. Then lastly, substitute 2 and 22 in equation 2.
Let's now use elimination method. We have our example here. 3x plus 2y equals 16 as our first equation, then 4x minus 2y equals negative 2 as our second equation. The system is now ready for elimination as it is. If we add both equations, the 2y and the negative 2y from a zero pair are eliminated from the resulting equation. For our first step, add the two equations. Then, divide both sides of the equation by 7 to cancel out the x. For step 2, we need to find the value of y by substituting 2 in 4, x in one of the original equations. I chose the first equation because every term in the equation are positive. Then, divide both sides of the equation by 2 so that you can cancel the x. Our x will be x equals to 5. For step 3, check the accuracy of your point by substituting in both 2 and 5 into the second equation, the equation we did not use to find y. Then they are equal. So, since negative 2 is what we're supposed to get, we did the work correctly. The solution to the system is 2, 5.